Hello everyone. So today we'll be talking about static and dynamic modeling. So as a reminder of what we discussed during the previous lectures, like in the previous lectures, we talked about the requirement engineering phase. And in this phase, mainly our goal was just like to collect the expected requirements from the client and then trying to write in a kind of a formal document that summarizes all of the requirements and their description. And also, we talked about the way to visualize these requirements by kind of drawing the use case diagram, for example, and also the important use case. There is kind of a template that describes in more detail the interaction in order to finalize specific requirement. So also we discussed details related to use case, like the textual description, like the dictionary, and so on. For today, we will start talking about how we can design these requirements. And the main reason is to implement them later. Okay, so all this is kind of a preparation for the implementation phase or the coding part. Okay, uh, again, don't worry because coding is not the essential. This is not a coding class, like I mentioned in the start. So we will learn about coding, but don't expect that we will be coding the whole project. Okay, just to let you know. So whatever. Mainly what we will see is the static modeling phase, okay? And we'll be talking mainly about the class diagram. So this chapter is kind of a little bit long, and I don't want you to feel already that the videos are long. This is why I'm splitting it into two videos. So the first one will discuss about static like modeling, and the next video it will be mainly about dynamic modeling. Okay, so for today, so for the static modeling, we will be talking about the class diagram. Okay, and then like in order to model the interaction, we will be talking about sequence diagram as example of dynamic modeling. Okay, so uh, as I mentioned, we will only focus on static modeling. And the topic is mainly about class diagrams, okay? So today we will learn about class diagrams. Here we go. So we always need to make sure that the requirements that we already collected in the previous step are properly linked to our diagrams or our design, let's say. So, because this design is later going to be translated into kind of implementation, like I mentioned. Like one mainly of the, I would say, the main challenges that we often face kind of uh, details that like at some point, probably if you even discuss with your group members, you can like ask the question, how are we going to determine how much details we should include at some point, especially when we're talking about the class diagram? So shall we include all the details? Shall we stop at this level, or like, is this enough? So this is probably kind of discussion that you could have concerning the class diagram. And always remember that the main point is that you want to effectively like represent the requirements. Okay, you need to effectively like represent how like kind of you can ensure, I would say, consistency between the different diagrams. So while designing your class diagram, you need to keep in mind that you already have some use case diagram. You need to respect that. Okay, so for example, if you are already designing, let's say, the use case diagram, let's talk on this example in particular, you are going to ask yourself, how can I make sure that this use case diagram is consistent? Okay, the right word is consistency. So how the use case diagram is consistent with the class diagram, which represents the design and implementation aspects of these like kind of same requirements at the end. Okay, so this is the big question, this is the most important point, and this is what you need to make sure like you are like doing. Okay, so the main step in order to start thinking about how we can design the requirements for implementation purpose is to think about modularity. So you need to think about the modularity of your architecture. And when I say modularity, that means how can I group together the requirements that are similar into one module. Okay, like for example, if, or let's suppose that you have different requirements, and let's say about kind of checking the login. I given the example of Facebook last time. You have an account, so you are going to log in, and in this case, checking the login, like it's kind of checking the status first of the user, the like identity. So all these requirements could be grouped together because they are at the end related to checking the login. Okay, and for if I'm saying that we're going to group them together, that means that we are going to put them all in one single or same module, which is about probably security, because we want to make sure that this is the profile, this is the user, and it's kind of like a checkup. Okay, so after defining these modules, the next step is like let's say how to define from this, I would say, big main modules, some submodules. Means within this module, you are going to include kind of submodules, because mainly sometimes some modules could be large. Okay, and we need in this case like kind of either decompose them into some submodule, or also we need to probably change our design completely at some point or in some cases in order to avoid having very large modules. Okay, we need to take care about this and consider this mainly. So what we do is that we do the decomposition step from the requirements level to design level on multiple iterations. So what we try to identify first is the big idea, I would say the big module, and then after that we try to decompose them into some modules that again, like there is no recipe for that. I won't say you need to do this and this and this and that. There are no steps. I'm just explaining the overall idea. And so it depends mainly on your design. It depends on your taste. It depends probably on the discussion with your group members. It depends on the way how you see things or how you look to the requirements and to their dependencies. Okay, so everything in general like could have different design at this stage. Let's say in the particular case, I would say of the class diagram. This is why I will note, and I will probably mention this again and again, that when it comes to practices related to use case, probably there is no rule mainly, but requirements, we try kind of extract the common things. So mainly if two different people kind of, they will have very similar diagrams. But for the implementation and the class diagram, we can have different like results, and that is very normal, because if it makes sense, it is correct in terms of syntax, in terms of the way we are like designing that and presenting that, so it's fine and it's totally like even expected. Okay, so just this is my remark. And now let's move on to our like design steps. So the first step like is to review and define your use case. Okay, so mainly this you are working on for your project. So you start with kind of, I would call it a draft of use case. So you need to make sure that your design diagram, and especially like later even your class diagram, like it specifically like mainly is consistent in particular with your use case diagram. Okay, so from there, try to identify mainly the main modules, like I mentioned, the submodules. And in a class diagram, what we call module is mainly, or is like actually represented by a class. Okay, later I will explain what is the class, how to represent that, and so on. But for now, try to note that each class can like later be kind of decomposed into multiple smaller classes, and then each class may contain also several functions. And in order to describe a class, we have the word attributes and so on. We will discuss all this. But in general, this is kind of the main paradigm for UML, as I was telling you last time, of the Unified Modeling Language. So we define different functions within various classes, and these classes can have relationships between like one another. So just try to clarify the overall idea so things will be clear for you. So here, for example, are more definitions, I would say, about different elements that you can find in your class diagram. Okay, so the first type of element is classes, and classes represent the types of data themselves. Okay, so like for example, I can have a class person, I can have what I'm trying to represent in my later in my program. But now from my use case, what I can have person, can have, for example, chair, I can have computer, I can have these all things that can I represent with like a class. And so for a class, like mainly we have like a specific syntax. I will explain this for you later, but keep in mind that a class is a way to model something that already exists in a way to represent it later to your computer. For example, university, class, student, professor, person, no matter what, we can like try to model that as a class. Okay, so there are some like probably I would say characteristics for a class, like it has some relationship with other classes, it can have some attributes, it can do some kind of operations, and so on. So this is what I will be talking about mainly. So these entities are in general extracted again from use case. You are not going to have, for example, your app, it's about like, let's say, fitness app, and then you are kind of having class animal or class that has no relationship with the topic or what are you doing. So you make sure that you are always like consistent with your use case, and you are extracting like these entities from your use case. Okay, so you can think of I would say the actors. You can think of the use cases themselves. So it can be the actors, like you can represent them by class. Different types of actors, they can be different, like subclasses, for example, and probably some important features also of your use case could be translated into big classes, and or I would say big modules, and then you can decompose that later. Okay, so between these classes I have also relationships. So mainly I just try to show you. Okay, later I have the presentation, but I said that class mainly has a name, some probably attributes right here, and some functions, and it can have relationship with other classes. And for a given class, we have like association. So this is association, just the link with other classes. And also the attributes is kind of a simple data found in a class in their instances. Like for example, if I have class, let's say person in general, later I will take an example, another example. So if I have class person, and I'm also again sorry about my writing here is catastrophic, but I want to say person. Okay, so person have attributes like, for example, ID or name, And so attributes, we write them here, okay? Name looks like a name, but whatever. And functions like a person, what he can do, for example, learn, sleep, maybe eat. It depends, okay? So here we have a class, and so mainly this is the class. It has a name, it has association with other classes, it has attributes, it has operation. Now the generalization is kind of group classes into inheritance or hierarchies. Means that if, for example, and this is the same, usually you get it from your like use case. So sometimes in your use case, you remember this nice, gentle stick man. So imagine that in your use case, you have this stick man and it's class person, okay? And we say, or let's say that we are reading somehow in our specification or in that like description, that we say that for a person, you can find like teacher or professor, and you can find a student, okay? So at the end, a student is a person, professor is a person. So you have the class professor and the class, oh, sorry. I am straight moving to talk about classes, but mainly here, I just want to represent things at use case level, okay? So let's stick with the use case level. So how to present the generalization in this case? So we still again have this stick man, nice stick man. So one for professor and one for student, okay? So we can have something that looks like this in the use case. Now, these stickmans or these actors, if I'm going to translate to the, I would say the class diagram, they can have association with other classes, and there can be this generalization link. So for each actor, it could be seen as a class. So we have the class person, okay, and we have here subclasses like professor, for example, and the another subclass for mentioning the student, like here, okay? So this is very difficult to write. So I'm missing to write on the white or whiteboard, but it's fine, okay? So this is how it looks, okay? And so why we consider that professor and student, and it's kind of like they belong to the class person, because probably the professor have an ID and the student have also an ID. So it's better not to keep this redundancy, and we put the ID is the like kind of common characteristic or feature between both. So we put it in the, I would say, mother, like this main class, okay? And otherwise, there are some like characteristics for the professor, or sometimes probably functions, like for example, teach, or that student doesn't have, okay? And also the same for students that professor doesn't have. So this difference, this is what makes the two classes different. And the common thing is what like they take from the bigger class, I would say, okay? So this is the idea. Just I need probably to uh, delete all this so it don't stay with us for the upcoming slides. So I wish I'm making things probably a little bit clear. And so the idea now, I think it's more clear. So we have the classes, the association. Now the attributes, I probably can come back to this point. So the attributes at each class, I say like should have operations, and these operations are also called functions. Like I said, person, eat, sleep, whatever, this is a function. So later in coding, at the coding level, we will write these functions. And so in general, they represent the actions that could be performed by that class, okay? class students, let's imagine that a student registered to a class. So a student can access to a course description, and probably these are different functions that enable a student to take kind of action. So this is an example of function in like for class student, okay? And probably now for the generalization, it's just used to create the submodules as I was explaining, okay? So, and why we do use generalization mainly, as I mentioned, it's a way to make your class diagram more easy to understand, or I would say it improves the reusability of your diagram, okay? So this is the example I was giving you, and mainly this is the importance of the generalization in general. Now let's take or have another example. So let's like see through the this is the particular like class student, okay? So classes, as I said, they like represent or the real world entities or system like concepts, and they could be in general easy to extract from the use case, okay? Like for example, I was extracting from the stickman or actors class student, class professor, class like a person, and so on, okay? So they are organized in general into objects where each of these objects have properties like, for example, the attributes I told you, like name, age, family name, okay? And by the way, we try to make the most important attributes, okay? Kind of here, like we are putting the date of birth and the name. And so if you see here, we have the date of birth, date. So here we have the type. Always we write the name of our like attribute. And so one of the students was asking about what is the difference probably between one attribute and a variable. Okay, so at this level we talk about attribute. Okay, and I started moving probably towards variable because I started introducing the types of these attributes, which is going to help me later in a coding level or in the implementation stage to define these as variables. Okay, so now just we try to focus with the like attributes. Okay, so we have in general like the organization, as I mentioned, it's like we have different objects, date of birth, name, and so on. And also we have the functions, we have the properties or the actions, I would say, that that this entity can take. Like for example, a student can like get age in years. So we can get the age of the student in years. This is going to return an integer. And for example, get age in days as well, probably if we need this for some reason. So these are examples of functions that we can take, okay? So if you're familiar with the object oriented or Java, I would say, coding class, you took this previously. So I just want to give a quick like what do we say? I would say a quick information because I'm not sure if just it's a reminder or whatever. So usually when we have some attributes, we can get them, okay? Get means we access to this method, okay? So I have get something. This something is the name of my attribute, like get date of birth, get age, get name, get whatever, okay? And it's a method, so I need to just put this like parentheses. And also, this is just to get an information. We are only going to kind of read information. There is another method, which is the set method, okay? And set, we set anything, like something that we can edit, we can modify. So we have set something, I would say. So for like, usually we have methods like are known, okay? The getters and setters, okay? They are known as getters and setters. Just keep in mind, because you will always see this like get something or get something or set something and so on, okay? I think just kind of this, I want to let you know or remember this information, because later you will always see this get and this set, okay? Now let's like move on like to like a way like, or to understand more, a way how probably you can see a class represented. So the very simple way is to represent a class like by a box, and I really don't like this. I don't recommend this. For me, I think the best thing for a class is to have this like kind of arrangement, having it divided by three, the main like rectangle. First, you have the name of your class, then you have your attributes, and then you have your methods, okay, or functions. So some people only use the rectangle. This is okay, this is fine. Some people, if they don't have attributes in that class, which is rare, for me at least, we need to have one, expect if in the description they don't mention probably. So they only keep the methods. Sometimes they only have information about the uh, attributes. They don't have information about the methods, so they only keep the attributes. But the ideal case, which is I recommend, is having the name of the class, the attributes, and the methods, which is probably much more better, is to have information about their privacy, okay, or like they are public or private or protected, and we will see this. So there are two types of class diagrams, to be honest with you. There is class diagrams that we do in the like first stage, which are okay to just represent like only with rectangle, or like only like without specifying different types of attributes, or without specifying the privacy or visibility of the methods. But the final, I would say, class diagram must be complete, and that is going to be like the last step before implementing. So last step before implementing, you need to see in your class diagram how things are looking like, because later, if you are familiar probably with the coding, I can quickly go through that. This like class is going to be translated as like a class, okay, in Java, for example. So this is mainly public. You remember this. Hopefully you have some experience with the coding. So this is public class. What is the name of this class? Rectangle, okay? Rectangle. Okay. Sorry about my writing again. And so what we do, we open like these curly brackets, and we need to define the attribute. So here this means this is a private. So private, even if you're not familiar with the syntax, don't worry. Private, what is this type? For example, let's say it's an int or float, or I don't know what's not specified here. We're supposed to specify after the two dots in here. So, and we call it like height. And again, private, float, width. These are the attributes. And then like we start introducing the methods like public, or the getters and setters get area. So here we're supposed to have the area somehow, and the resize methods. Just this is giving the example, but we need probably to understand more what this rectangle class exactly does, how it works, and so on. So all this is what you see here is going to be translated in terms of code or implementation later, okay? Just I'm giving you an idea just to understand that it's okay in the first stages just to represent things like briefly. I don't need to put all the information maybe, but at the end I need to have all the details to make it easy for me like to just translate that in terms of coding, okay? So probably this is what I want to say or highlight when it comes to classes. These are my tips, and let's just try to like move on. Okay, now for a class, we understood how to represent that. I will consider the easy way, which is just the rectangle in which is the name of the class, but make sure that there is not only the name, the attributes and functions and so on. So here we have an association. So this mainly, this link between the two classes is called an association, okay? So, and when you are designing, mainly an association, it's like the link, as I mentioned, between the classes, which in general, like at least you must have each class in your class diagram have probably, or I would say minimum one association link with another class. So it's not common in general that you are having a class which is isolated. We don't have that. So like between here, what we have, the example, employee and company. So between employee and company here, there is a link. So there is an association. So this link or association could be like read like the employee, there is a relationship with the company. What kind of relationship is that? The employee works for the company, okay? So, and then each of these association, you need, like I said now, a company means one single company. So what we need to specify in this case is what we call the multiplicity. Multiplicity is like kind of the number, okay? So we can have, like here, for example, one-to-one association. We can have many-to-one. We can have like one or many, too many, and so on. So how to read, by the way, this star, okay? So this we can read one, but the star, just take note if you want, is equal in terms of just explaining means zero. It can be known, okay? Or many. Many, I mean star, okay? Or 0 to n, which means that you can have many elements and you can have no elements, okay? So, however, if sometimes in your description it requires that you have at least one. So, at least one, if we try to write this in terms of like multiplicity, at least one means here we have one. This is the lower bound, and then in the upper bound we have the maximum. It's a star, okay? Sometimes we can say at least I have one, and maximum I have I would say 100 employee in my company. So I would put the upper bound in this case. So sometimes it's not even one, the lower bound. Sometimes it says three, and minimum for a project, I will have minimum 3 students, maximum 6 students. So I represent things like this, okay? So for multiplicity, we can whether represent the exact number, like 1, like 3, like 5, like 10, or we can give an interval in which there is the upper bound and the lower bound. And if we only show the star, like in this case, star could mean, or it means mainly zero, like 0 or many, okay? Star means 0 or many, and if I want to make sure it's 1 or many, I make sure that this the minimum is 1 or minimum 3, or and then I have this double or 2 dots and then the star again, okay? So starts to say many, and it can include the 0. It don't include 0 only when if we specify the lower bound, okay? So this is mainly for the relationships. How to read that now? We can see, we read in this direction, okay? An employee like works for one company. One company, we read it from the side of the company. If we want to read from the opposite side, so here in a company, many or zero or many employees work. Okay, here let's read this one. Between the relationship between administrative assistant and the manager. So for like an administrative assistant, there must be at least one manager, means minimum one, maximum as many as possible, or no matter how much. And a manager could be like working with zero or many administrative assistants. Okay, this is just an example. Also, like for example, a company can probably have like one board directors, a single one, and a board director only for works for one company. Okay, like here in one like an office could be accessible, or it depends on the name or the relationship here that is mainly described in your text. So the office can have, I would say, zero or many employees, and here for a given or like an employee must belong to maximum, I would say, one office, or he can probably don't have office. Like me, I'm working remotely, so I don't have an office currently. Okay, so here it depends. And here we find like the person and the board directors. Okay, so person can belong or have, I would say, zero or many board directors, and the board directors can contain zero, three, or four, five, until eight maximum, people. Okay, so this is how to read this like kind of associations and multiplicity. Just let me remove. Okay. Now what we have is that here is clarifying kind of the relationship, and this is possible is to label your associations from where you bring these verbs. Mainly these, like I mentioned, it's specified in the description. Okay, so for better understanding, your association link can like be labeled, and the label is like the verb or relationships like you mentioned between, like for example, employee and company. You can use the title, probably works for in this case, or between like employee and office, it's better to use the allocated to. Okay, and for example, person is like board member, uh, as compared with, like I would say, the board directors, or within or among. Okay, and so the manager is supervisor for the administrative assistant. The administrative assistant is supervised by the manager. So when we go in one way, we just read it from the side, like here, for example, from the side of the manager means he is the supervisor. If heard from the side of the person, this label, it means that person is a board member. If we read from the opposite direction, we only simply use the passive form. Okay, like for example, the administrative assistant is supervised by the manager. Okay, okay, so this is kind of just example. And you know, when we translate this into code, it like it's usually used for readability. Then in order to understand kind of the purposes in general from these, or the relationship between these different classes. And when we code, so it will not be basically like needed to be named. So we don't translate that, only for the clarity, for better reading of your class. Otherwise, in terms of coding, like only maybe for readability purpose, we try to do that at this level. Okay, let's move quickly to the next part. So here, let's look to an example of multiplicity. Like here, this is the example of many-to-one, okay? This is many-to-one relationship between two classes. For instance, like we have company and employee and company. So company can have, let's say, 0 or many employees, but an employee must work exactly in one company. So it's not possible for an employee to be employed like with more than one company, or to be associated with like working without maybe even having a company. So the way we define this multiplicity really depends on the specific requirements, as I mentioned, and how the entities are linked together in your design, okay? And so another type is the many to many. So here we have the star sign for many. Here we have the star sign for many. And this means, for example, an assistant like can have one or more supervisors. So he at least has one supervisor, as I explained it. And each supervisor can manage multiple assistants, okay? So this is another type of relationship that shows that an assistant like must have a manager, and can, like, a manager can be responsible for many assistants. Just note that with the star again, it means that there can be any number of instances, including no, okay? Make sure, because this will be always used, okay? So 0 or many, just keep in mind. Another type here of multiplicity is the one-to-one. So for example, between the company and its board directors, what we have is a board of directors belong only to one company, and each company has only one board directors, okay? So in general, we use the one-to-one associations like quite rare, so you won't find this. So try to avoid using the one-to-one association. Probably it's kind of, I would say, unnecessary in most of the cases. Why I am saying that? Why it's unnecessary? Because I would say in most of the cases, when though you have this one-to-one, it's kind of, you can simply combine that into one single like class at the end. So person, it has name, and one person has person info, address, email, birthday. It's possible just to have it in one class person that is having all these attributes, okay? So that's why usually it's better to keep that information together in one class rather than separating them, okay? So one-to-one, try to avoid. Even if you have your class diagram, you see kind of one-to-one relationships, try to like put them together or combine them into one class. So here, another, I would say, more complex example is when you have multiple associations, links between the classes, okay? So you can, like in this example, group them, or I would say frame them within a package. And this like mainly is happening when like mainly we have a set of classes that can be fitting, I would say, within the same topic, module. Means there is some common thing. You will understand with the example. When I say passenger, I say booking, I say specified, specific flight. So in your brain, all this comes together in kind of booking passengers on flights. It's main topic. It's one package, okay? So this may be very important at the implementation level. So if you want to group several classes together so that they belong to the same, like inside a package, I would say. Later, they belong to the same feature, to the same functionality, like that, okay? So later when you move on implementation, that grouping will represent package level. And so, however, this step is, for now, I would say it's optional. It's usually done for larger systems where the system contains big modules. For us, even if we will have a use case, it will be mainly for booking passengers on flights, and this will be our single module. So we probably will not need this kind of high modularity, or will not work on managing many different class diagrams, but you can have this, like, it depends on the description, okay? But for now, let's just know that it exists, but not that much used in at least in our case. Probably in your project you can use that. Why not? If you have multiple like modules or different topics. So otherwise, let's move on to the association class. So sometimes an attribute can be associated with two classes. Okay, it can happen, and it's very common. Not very common, yeah, but this one is possible. Okay, so mainly we see this. Okay, we see this. For example, a function might be used by two different classes. Okay, like for example, in this case, what we have class student and course section. Okay, or in this case, like it's the same. So what happened, like we usually do, is to create separate class, and in this separate class it associates both these classes. Okay, between the student and course section. Here what we find, so we can have the association class called registration, and this makes sense because student, okay, can register. Okay, and student can have registration. Here it has the attribute grade, so the student at the end can have the grade, okay, in a specific course section, and that grade doesn't really exclusively, I would say, belong like to either the student class or the course class. That's why we represent it as an association class instead of attaching it like one of these two. Okay, so the student is having the grade for what? For the course section. Okay, so putting the grade only with the course section is wrong, because the student has that grade. Putting the grade only for the student is also wrong, because the grade, it depends on the course section as well. So this is why we use it here. So here we have many to many relationship. Okay, and so this is how it works. We summarize it here, but if we want to see it in a different way, so here the in the class registration, like we have it's connected to student and also to course section. So for how many grades? The grade belong to one student. Student could be having many grades, depends on the course section, if we can see here. And again, we read it this way, like the grade for we have one for the course section, one grade, and for a given course section we can have many grades. Okay, so but at the end here we summarize that, we remove these ones, and it's at the end a many to many relationship with this association class. Okay, so there is another type of association, which is like what we call the reflexive association. Like for example, here we have the class course, and for example, a course can have another prerequisite course. Okay, so which is mainly another course when it comes to the type. So basically each course, like for example, CIS-350, has in your case the prerequisites of computer information system, okay, or 163. So of course a prereq is kind of another course, so you have sometimes some kind of this reflexive relationship or reflexive association with the same class. Okay, so it's also rare, I think, but it exists. Also for readability reason, like you can specify that an association has one direction. You see here, so usually if we don't clarify that, it's bidirectional. This is why I always read from both sides. But if we specify the direction of the arrow, only we can read from here to here. Okay, we need to make sure that it could be used. Okay, and the main reason here is to limit the direction of an association. So we just add the arrow. Okay, and we're discussing already the other type of association link, which is the generalization. So in general, the generalization link is used to improve the readability, as I said, or reusability of your design. For example, you have animal, like you have here subclasses, and again, it depends type of the food they eat. There are also subclasses, so I just explained this. The most important that there are common things. This is the main class in all cases. Okay, and these subclasses are different, but still they belong to the main class. Okay, it's usually in terms of behavior and so on. So another type of association is called the aggregation link, and this is very important to understand in my opinion. So aggregation, you will see here this diamond. So the aggregation link means that one is part of the others. Okay, so for example here, a vehicle is composed of many here vehicle parts. A country is composed or contains many regions. Okay, so here it could be part of only one country or one vehicle here, the vehicle part or the region. Okay, so this is what we call aggregation link in general. So keep in mind, it's one is part of the other. Okay, we have the vehicle parts, they are many, but they belong to the vehicle. We have a country, we have the regions, they could be many, they belong to the country. Okay, so when do we use an aggregation? So these are two types. There are two types, I would say, of aggregation links. So one could be a strong aggregation, and the other could be a weak aggregation. Okay, so this is the example of strong, I would say, aggregation. So this is the case of strong aggregation. We call it composition. Okay, composition is that we need to make that sure that this diamond is colored with black. It's not like here, it's not colored. Okay, it is very important. So this type of association link, which we call composition link, you can see that the room in this case is part of one building. Okay, and one building is composed by multiple rooms. So basically, if you destroy one class, like for example, you destroy the building, so it's going to the class building, it's going to destroy the other class, which is classroom. For example, if you destroy the classroom or all of them, means there will be no building anymore. So the strong relationship when you color this diamond with the black color, it's when if you destroy one, then the parts are destroyed as well. Okay, and so basically if you destroy one class, it will also destroy other classes, just as simple as this. So if you delete the class building based on this strong kind of aggregation, which is, again, it's here with the black diamond. So you make sure that you color this. Okay, even if you are using pen and paper, and you make sure that you color this. Okay, so this is a strong aggregation, or we call it composition. So if I destroy class building, I have to destroy the instances of classroom. So it's necessary to have the class building to have the classroom. If I am going to delete the class building, this is what going to make it all rooms go. So this is what we call the strong aggregation in terms of the composition. Okay, here like are some suggestions of activities that you have to follow in order to find your class diagram. Okay, so you will be practicing this class diagram in your upcoming practice. So, and there are a lot of set of that. Okay, so first thing, let's like learn how to do that in general. So in general, what we do is to try to identify candidate classes. So after identifying all the classes, you need to identify the association link between them. Okay, we try to make sure these are the classes, these are the links, these are connected to each other, these are not connected to each other. Find also some possible generalization link, because usually we do have this kind of links. And then once you are done with this, you need to kind of start filling the content of each class. When I say filling the content, means you are like getting your attributes, your operations, so basically the functions for each of the classes. Then you have to iterate this process multiple times. For example, during like the exam or your proposal or assignments, try to make sure that you use your pen and paper, and in order to practice several times and iterate multiple times until you get your final class diagram. So once it's final, we can use the online tools like Star UML, I said, or that visual paradigm online, or whatever tool you would like to use to finalize the classes. And again, there is no recipe for that. There is no unique solution. It could be multiple. So try to make sure that you iterate this process multiple times, because the more you iterate, the more you will understand things, and you and your team members probably will have clearer version and of the class diagram. So after that, when you are identifying classes, try to make sure that you discover the classes by looking to the description of like the text. It's not the case in your project, but usually whenever you are working on practice or exam, there is a text. So try to make sure that you are looking at the text, because you are going to bring that classes, names, and so on from the text. So stick to the like text. So try to make sure that you identify probably all actors as classes, for example, all the different nouns in your text that could be represented as a class, and so on. Okay, so you're not going to think of them, you are going to just read very well the like text, and then from that you're going to extract. Okay, and try to look at many like nouns in your text, because these nouns in general that are in like your text description of the system, they represent a class. Okay, the even like relationships or like can represent the generalization. If, for example, as I said, the person says the student, then it says the professor. So you can understand that these are like subclasses from this, and so on. Okay, so try also to eliminate the redundant classes. So you will notice that at some point I have some redundancy, so try to avoid that, probably remaining the ones that are like very bad, and you keep doing this, so back and forth and so on. Okay, so after that, now when you try to find the attributes and association links, which is here the easiest step, I would say, because you have already defined and identified your classes. So we're just going to take a look on the verbs for the verbs in your text, and in order to identify the association between them. Okay, so it's easy to just find your attributes and associations. If there is any like labels for your association, you'll understand the verbs in that sentences, like the employee works for the company, so you have works for, this is the relationship, and so on. So also you maybe need to look to some keywords like part of or composed, like, or controls, is connected to, is related to, it like has as part, like is a member of, has like as members, and so on. So all these are words that can exist, and you will find them written, okay, in your text. So you will understand this kind of association, okay? So in general, this should be an association link between the classes, like the nouns that you will find, and these are the mainly how it could be presented, okay? So then after that, you can try to look for information. You try to look for, I would say, information that could be related to each class. Like you can find, for example, the type of variables that you identified for the class. And it's this in general also a very easy step, okay? And for generalization link now, you can create some abstraction if you can find some redundancies in the class. Like you find, for example, some classes have the same functions, like, for example, a class student has probably some actions like register a class or access to grade. So, and then other class has exactly same function. So in this case, it would be another class that can have like student administrator, for example. So you can have both administrator and student linked with generation link, creating a super class, which is the class person, okay? Like the example I given you, professor, student, class, person, okay? So in general, once you identify the classes, their actions basically, and their functions, you can decide which one could be linked by generalization, okay? So then as you identify the classes, try to make sure that you identify names as responsibilities, basically like the attributes of these classes, okay? And then also include the operations that represent the functions of the classes. So again, it's easy to identify these like functions once you have identified correctly, I would say, or properly your classes, like then it's going to be easy for you. After that, so once you are done with the design of your like class diagram, you may start thinking about implementing this later. And as you know, probably there are some tools that can generate the code, at least pseudo code from your class diagram, okay? So these are things that you might consider. And now, one thing that I want to emphasize, and here is that again, there is no unique solution. You can have multiple potential designs. So please make sure you don't fight with your groups, because everyone will think, team member, I mean, everyone will think they're having the correct answer. No, maybe everyone is correct. So we try to discuss and try to come up with a common like solution that everyone agrees on, and that's it, okay? So because it's mainly very subjective, you can have multiple potential design, as I'm mentioning, and nobody will have one unique solution for design, but we try to make sure that, okay, we try to converge towards one, at least we choose that. So as long as you try to identify classes correctly and their function, their association, their links, so it's totally correct. It could be example that some classes you could merge them together into one class, but you didn't. That's fine also. But the most important part is to identify most of the responsibilities of the class and the association between the classes, the attributes, the functions, and so on. So you will be practicing, don't worry. You will be practicing whether in the upcoming practice, you can be practicing this even part of your project. So this is mainly the focus like for upcoming project steps, and like this is going to be like for your practice as well, practice and project, both of them. So I think that it's enough for today, and for next time we are going to discuss the dynamic modeling, as I mentioned, and probably the sequence diagram. Okay, Thank you so much. And I think that if you have any questions, please never hesitate to ask. Post your questions in our Discord channel. It's fine not to ask private messages. I encourage that. I respect that. I do my best to answer everyone, but I also encourage the group discussion. So sometimes you answer someone else, maybe had the same question. So when I'm when you're asking, I try to answer you, probably I'm answering other people at the same time. So I want to spread the information probably more, and this is mainly my message. I wish that everyone is understanding, and if you have any questions, please never hesitate to ask me. Thank you so much.